I know in the first video I kind of skipped over this first page and jumped straight into filling out the empirical rule, so I want to go back and hit this highlight. At the top of this page I have the shapes of distributions that we went over in the previous section, and the empirical rule is true for this normal distribution here, or sometimes it's called the binomial distribution, the bell-shaped curve. So that one that we saw when we went over the different shapes of distributions will just be this, the empirical rule is just true for that normal distribution. All right, so let's go and look at an example I've got here. And these always are really long in the directions. They're kind of setting up a scenario. And in all of them, they tell me the mean and the standard deviation. That's what I really need, is the mean and the standard deviation. Those are the important numbers. This, that it's from 15 to 90 miles, that's actually not important. I'm not going to be using those numbers at all. So kind of a red herring there. So I'm going to start with the mean in the middle, because if we're in the middle, that was the middle part. That's where I'm going to start at. So that is 42. And then my bottom part is kind of like my ruler. You can think about it being like the axis or a number line. I'm going to add when I go to the right. I'm going to subtract when I go to the left, because smaller numbers are to the left. So here is my mean. And I'm going to do this 3 times so I can fill in those percents from the empirical rule. So I'm going to add 8. And I'm going to keep adding 8 3 times. And then I'm going to subtract 8, again, from this mean right here of 42. I'm going to subtract 8. Then I would subtract 8 again. And then I would subtract 8 one more time. That number line changes with each problem because it's based off of the mean and the standard deviation, but the percents don't. These are the empirical rule. So I'm just going to fill in my percents that I have to know. They're not going to be given to me. They're 4 numbers. They're the same on the left and the right. They're the same numbers that I went over before. There they are. I know it's kind of small to read, but we've got the bigger one that we filled out on the other page. All right, so my first problem here wants to know what percent, or this one says what's the probability. So I'm going to write my answer as a with probability, we're going to write it as a decimal. A percent, we would write it as a whole number there. So like 34 would be 0.34. Just kind of pay attention to those. I've got one that's a percent down here for the second example. So the probability between 18 and 66. So I'm going to add up all the numbers between 18 and 66. You wouldn't have to show this step, but I will show it just so you know where my answer came from. So if I add all those up, I get 99.7. And since it wanted as a probability, I'm just going to write that as 0.997. If it said percent, I would leave it. Probability, I would write it as a decimal. And all the problems really work that way. There's not a lot to most of them. I'll change colors. We'll do red now. Shorter than 34. So here's the 34. Shorter is going to be less than. So I'm going to do everything that's less than that. 0.15% plus 2.35% plus 13.5%. Adding those up gives me 16%. So writing it as a probability would be 0.16. Why don't you go ahead and hit pause on the video and see if you can give C, D, and E a try, and then come back and check your answers. Coming back from the pause here, we've got more than 58, so here's 58, and I want more, so I'm going to go to the right, so that would be 2.35% plus 0.15%. That's going to give me 2.5%. And as a probability, that means you have to move it 2 decimal places, 1, 2, or divide by 100. So I get my answer, or 0.025% for the probability. For D, between 26 and 50, so 13.5, 34, and 34. That would give me 81.5%, which I would write as 0.81 0.815 for the probability. That's the answer for D. Getting all smushed up here. And the answer for E, less than 42, I would add up everything to the left of 42. This one, if you do enough of these, you might see a pattern with them. This one is the mean, 42 is the mean, it's right in the middle. So that's always going to be 50%. Half is above and half is below. So as a probability, I would write that as 0.5.